Okay, so we're going to go over sum of interior angles, which we've made a very funny initialism. It's technically called initialism because it doesn't really spell a word that we can sound out. Asoya, I guess. Sum of interior angles is this formula here. And what it refers to, the variable n is the number of sides in the shape. Okay, so n is number of sides. So our first shape is a triangle. Therefore, what is our n for this question?
3.
Great. And we're just going to go through the list really quickly.
4.
Square, genius. Pentagon.
5.
Super weird shape.
Is that octagon?
That's not an octagon. Let's count them. Okay, so here 1, 3, 4, 5. What do you think it ends up at?
10.
6, 7, 8.
Pentagon.
Couldn't tell you what it's called off the top of my head. I don't know. But that's okay. And essentially the last one's to prove that this formula works all the way
Oh, I
through.
think it's a decagon.
That might be right, actually. I don't know. I'll look it up. Okay, importantly is we're trying to find the sums of the interior angles. So, do you happen to know what the sums of the angles inside of a triangle add up to?
180.
Yeah, that's right. It's a rule they were taught, but we're not really taught how to find that rule. So we know that our SOIA, this funny little initialism we made, should be 180. Should equal to 180 degrees. What about for a square?
Shoot, I should have written this down.
No? Yeah, and it's not commonly told. Okay, and you know what?
360.
You're right, it is 360. I was going to solve it, but that's a good one. Now, we really don't tend to be told what these shapes are because they're not common use for us. So let's see if our formula technically works. So our sum of our interior angles, so I'm just going to say the sum of the triangles is equal to 180 times, our n in this case is 3, right? And what is 3 subtract the number 2?
1.
Yeah. And 180 times 1?
180.
Yeah. And that made sense, right? 180 degrees? That's what our triangle was. So we got it. The sum of our square. 180 times our n in the square was the number 4, right? 4 subtract 2 will give us
2.
Yeah, and what is 2 times 180?
360.
That's right. So the sum of the interior angles for our square is 360. And that makes sense, right? Because if a square is 4 90-degree angles, 4 times 90 is 3 equals 360.
Also, you could divide it into 2 triangles.
Yeah, you could also divide into triangles. Excellent. And you can do that for like quite a few of these types of shapes. Anyways, our next one, sum of our pentagon. Now, and we better make this clear. I said the word square, but this technically is any 4-sided shape. Okay, I just used the square to represent it. Our pentagon. Our pentagon has 5 sides to it. So what will 5 subtract the number 2 be?
3.
Yeah. And what is 180 times?
540.
Yes. Wow, you did that very fast. 540. So this would be 540 degrees.
Math robot.
And then finally, okay, sum of, what do we call it? Decagon? That might be right. That could be completely wrong. Who knows? 10.
I mean, I called it a tentagon at first, but I thought that sounded too much like tentacle.
Kind of sounds like an octopus. Okay. 10 subtract 2 is 8. I already did that for us. Now, here's our difficult one. What will this be?
I think.
A very big number.
What do you think? Tell me what you think. Just say the numbers. You don't have to say the whole number. What would each place be? Give it a guess, and then we'll do it on the calculator. There's nothing wrong with guessing.
18000.
I'm pretty sure it's this. You tell me if I'm right. Check your calculator.
Yeah.
I'm pretty sure that's the number. Let's tack. 8 by 180. Yay. So that has an interior sum of the angles of 1,440 degrees. So all of those equal 1,440 degrees. So this rule can be used for any shape as long as we know the number of sides. Now on top of that, sometimes they'll ask you for, and I guess we'll kind of get into this, maybe we'll use our pentagon. Sometimes they'll ask you for, or they'll give you information about the exterior angles. So remember, this was just the interior angles. So we were finding out the sum of the interior angles. Now this is a regular shape. In this case, this is a regular pentagon. Okay, in a regular pentagon, anytime something is a regular shape, it means all the sides have the same length. which therefore all of the angles have the same length. That's what regular means for any type of geometric shape. Sometimes what they'll do is they'll ask you, well, tell us what the sum of all these exterior angles are. So they'll kind of do this, and they'll want you to add up all of these. And these are technically, the best way to do it is kind of like that. Extend this way, extend it this way, okay? These are the exterior angles, and they're also known as supplementary angles, okay? And a supplementary angle is two angles that add up to 180 degrees, okay? So sup equals 180 degrees. Complementary add up to 90. So we would actually have to find what the interior angle in this one would be. Since we know it's 540 and there are how many angles in this question?
5.
5. Okay? They're all equal. What can we divide this by to figure out what one of them are?
5.
Yeah. So let's do 540 divided by 5. So we're doing a little side work here on our pentagon. 540 divided by 5. Okay? And that's going to equal 108. I think that's 108.
Yeah.
08. Yes, 108. So each of those interior angles is 108 degrees. Okay. But they want an exterior angle.
So 180 minus 108
Perfect.
will
180
equal whatever the
minus
outside
108.
angle is.
is going to be, anyone know?
Shoot, I had it.
72, that's right. That's 72. Okay. And what if they had asked us, okay, we're doing a lot of extra math here, the sum of the exterior angles? Well, what are all these, how many exterior angles are there?
5.
It's 5. And what do we know each of them is?
72.
So how would I find the sum of them all?
72 times 5.
Excellent. Very good. That's a lot of extension in math. And this is going to be 360, I think. Oh, yeah. I believe that's 360. Just check with your calculators, but I think that's right. So you could kind of follow that anytime they asked for exterior angles to something also. It doesn't have to be a regular shape. We just happen to use regular shape in this one, okay? Thank you, Trixie.